day 2 of 5.2, we really just looked at simplifying radicals, and we looked at doing that with numbers, making sure you could break up a number into a perfect root times something else. So we're kind of going backwards from that multiplication. And then we also looked at being able to do that with variables. So if you look at the beginning part of 5.2, you see that we basically worked with numbers, cubed roots, square roots. We actually even did a 7th root. Then we threw in looking at variables as well, and when is it a perfect root and when is it not, and what do we do when it isn't a perfect root. And then we kind of gave you pretty much all of those same kinds of questions. We did when we got to the bottom, we actually also looked at simplifying, but then going back to that adding like terms that we did in the first day. We also looked at the very end, writing it as fractional exponents. So you first have to write it as a radical, and then you're going to do what you did on the top of the page. Okay, so that's kind of what we looked at on day 2, is just simplifying. Can you do it with a number or a coefficient, and can you do it with variables? So let's talk about numbers first. So when you have something like the square root of 32, what you need to do with square roots is you need to think of, I want to break this up into two things that multiply together, but it has to be, one of them has to be a perfect square, because I'm dealing with a square root. So what you might want to do is you might want to just write the perfect squares. 2 squared is 4, 3, which goes in there, by the way, so we could break it up into the square root of 4 and the square root of 8, but let's keep going. 3 squared is 9, 4 squared is 16, 5 squared, 6 squared, 7 squared. So you could just write these down, and again, you can use your calculator to figure those out. I'm just squaring 2, so this is 2 squared. I'm squaring the 9, I'm squaring the 4, or squaring the 3, squaring the 4, squaring the 5. So that's all I did to get those. So now when I'm looking at this list, I'm looking at which of these, and I'm trying to find the biggest number, is a factor of 32. And so when I get to 16, and again, you can use your calculator. You can take 32 divided by 25, doesn't go in there evenly. 32 divided by 16 does. It goes in there twice. So I can break this up into the square root of 36, or 36, square root of 16, sorry, and the square root of 2. Alright, so I'm just looking at which ones of these go into 32, and when I tried 16, it works, so it's the square root of 16, square root of 2. The reason I picked the 16 is now the square root of 16, I circle it, I can simplify it, it's 4. So now I know I have 4 times the square root of 2. So let me just try another square root. Let's say I have the square root of 500. So I'm thinking of perfect squares, and again, you could go through this list. I know 25 goes into there, but I want to find the biggest one, and if you kept going with this list, 10 squared is 100. So I know 100 goes into 500, so I'm going to break this up into the square root of 500, or square root of 100 times the square root of 5, sorry. Okay, square root of 100 times the square root of 5. I did that because I can circle the square root of 100. Square root of 100 is 10, 10 square root 5. Now, I do want to talk about what if you don't find the biggest one. So let's go down here. Let's say you decided you want to use 25, because 25 goes into there. So you can say, all right, I'm going to look at the square root of 500. Square root of 500 is the square root of 25 times the square root of, let's go in there, 20 times. Okay, so you could do that. Circle this. Square root of 25 is 5. 5 square root 20. But what you have to realize then is that there's still a perfect square that goes into 20, so you're going to have to do it twice if you don't find the biggest one. So now you can break up 20 into the square root of 4, because that's a perfect square, and the square root of 5. So I still have this 5 out here too, don't forget, that has to come down, but I'm breaking up the square root of 20 into the square root of 4 times the square root of 5. And so now I circle, square root of 4 is 2, 2 times 5 is 10, 10 square root 5. So I get the same answer as I got up here, but it took me 2 steps to do it. So if you can find the biggest one, it will save you some work. So if you wrote it as square root of 105, you can do it in one step. If you didn't find the biggest one, now you have to do multiple steps to get there. Okay, so just so you realize, you're working off of this list when it's square roots, and if you don't find the biggest one, that's okay. You just have to then make sure your answer, there's not another one in this list that goes into that number. All right, and again, cubed roots are kind of the same thing. So if I do the cubed root of, let's say, 16. All right, the cubed root's 2 to the third. So I'm thinking of all the cubes. 2 to the third is 8. 3 times 3 times 3 is 27. You can use your calculator for these. 4 to the third is 64. 5 to the third is 125. So again, I'm just looking at perfect thirds. Each number raised to the third power. And so I'm looking at this list for the cubed roots. I'm looking for any of these that are a factor of 16, and right away I see 8. So I know that I'm going to break this up into the cubed root of 8 and the cubed root of 2. So again, we're doing that multiplication backwards. Cubed root of 8 is 2, so it's 2 cubed root 2. All right, so that's working with numbers, and if it's a fourth root, you just have to say what's 2 to the fourth, what's 3 to the fourth, and do your list in fourths. All right, so that's kind of working with the number piece. Working with the variable piece. When you take something like the square root of x to the 10th, what you might want to do is think about putting that back as a fractional exponent. Remember, it's x, your base, raised to the 10 over whatever your root is. So 10 over 2 power. So that's that skill we learned in section 1, that you can convert that. That becomes x to the 5th. So when I take the square root of x to the 10th, all I'm really doing is taking 10, dividing it by the root. If it comes out evenly, like 5, then that's your answer, x to the 5th. So when it doesn't come out evenly, something like x to the 7th, now when you take 7 divided by your root 2, it doesn't come out to an integer. So what you can do is say, all right, I'm going to get it to something that is an integer. I'm going to break it up like we did with the numbers. I'm going to say it's the square root of x to the 6th, because 6 is divisible by 2. What's left is the square root of x to the 1st. So I just broke up the x to the 7th into x to the 6th and x to the 1st. And so now, again, all I need to do to simplify this is I'm really just taking my exponents and dividing them. So I'm going to take x to the 6th divided by 2 power, which is x to the 3rd. And I have to leave the square root of x. So I could simplify this one. I can't simplify that one. So when I have something like the square root of, let's do a to the 5th, b to the 4th, c to the 8th. All right, so when I look at this, 5 divided by 2 is not a perfect square. So I have to think of that as the square root of a to the 4th, because that is a perfect square, times a to the 1st. b to the 4th already is, so I'm going to leave that alone. And c to the 8th is. So if it is an even number, if it's divisible by your root, then you just leave it, because now I can circle those. I can actually simplify anything that is divisible by 2. So now when I take a to the 4 halves, that's a squared. This would be 4 divided by 2, b squared. This would be 8 divided by 2, c to the 4th. Anything that's not circled stays under the radical. All right, so let me do one, let's do a cubed root. Let me do cubed root of x to the 5th, y to the 2nd, z to the 4th. All right, now again, 5 divided by 3 doesn't go in evenly. So I need to come up with something that does go into there evenly. So I'm going to do x to the 3rd, because now 3 divided by 3 comes out to 1. What's left over? I still have 2 x's I have to multiply to get x to the 5th. So I broke up the 5 into a perfect cube, and then what's left over? Y squared is already smaller than 3, so I'm just going to leave it as the cubed root of y squared. I can't take any perfect cubes out of that. This one is bigger than 3, so I can take out again a cubed root of y to the, or z to the 3rd. I'm left with a z to the 1st. All right, That's a z there. Okay, so now let's circle. That's a perfect cube because it goes in there evenly. This is not, this is not, this one is. So the circled ones I can simplify. 3 divided by 3 is 1, so x to the first. Here for the z's, 1 divided by 1, or 3 divided by 3 is 1. So z to the first. And then what's left is here. So I have to put the cube root of, I've got an x squared, I've got a y squared, and I've got a z. So whatever you don't circle, that has to stay under the radical.